Hello, everybody. My talk today is hate speech detection from CodeMix Twitter data of Bahasa Indonesia and East Java dialect of Japanese languages using machine learning models. As a brief introduction, my name is Yaya Heriadi. I am a faculty member and researcher at Binus University. So before I start, let me explain some basic concept in this study. According to Encyclopedia of the American Constitution, hate speech is defined as a speech that attack a person or group on the basis of attributes such as race, religion, ethnic origin, national origin, sex, disability, sexual orientation, or gender identity. Hate speech detection in social media has raised global concern because online hate and radical narratives has been linked to current surge in hate crimes and an increase in youth suicide that result from social media, according to Johnson in 2019. Also, hate speech is a sign of intolerance and discrimination, which has been linked to violence toward minorities. Code mixed languages is defined as alteration of two languages within a single discourse, sentence, or constituent, or the use of two languages in a discourse, sentence, or constituent, uh, which are defined by Poplak and Heller. And according to Myers and Skelton in 1993, code mixed languages is the use of words, phrases, or sentence from one language into speech or writing in another languages. One mixed text cannot be analyzed using monolingual-based method as it is typically containing misspelling word or non-standard grammatical structure. Sentiment analysis is a process to extract polarity of positive or negative sentiment on the subject being studied in text or document, according to Nasukawa ND in 2003, and sentiment analysis can be used as a basis for sarcastic detection or hate speech from text. Now, machine learning is defined by Samuel in 1959 as a branch of computer science that studies algorithm design method capable of learning or adapting to data pattern without being explicitly programmed. Tom Michel in 1997 defined machine learning as a collection of algorithms that learn from experience E with respect to some class of task T and performance measured by P if each performance at task in T as measured by P improves with experience E. Now, learning types of machine learning um, can be categorized as supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. And some example of machine learning models are support vector machine, logistic regression, naive Bayes, TNN, random forest, and gradient boosting trees, to name of the view. Now, hate speech detection is important because popularity of social media in Indonesia has motivated many studies to address hate speech detection problem for text in Bahasa Indonesia. Some social media such as Facebook and Twitter prohibits hate speech in user posting, according to Mark Aveni et al. In 2019. Automated hate speech from text in Bahasa Indonesia is a challenging problem because Indonesian are bilingual speakers mostly, so that it is common some word from regional languages or local languages inserted into their utterance in Bahasa Indonesia. So hate speech detection problem can be formulated as a classification problem. According to Valada, Oliveira, Brooks, and Burgert in 2016, hate speech detection can be formulated as follows. Given a label data set comprises n pairs of samples x and y, in which x is a text representation and y is a label categories, and sentiment categories are assumed to be the result of mapping from x to y. And problem in sentiment analysis is how to predict this function by using machine learning models, or can be any other models. But if you use machine learning models, and the issue is how to predict the model parameters by minimizing a predetermined objective function. So this is the research method that we use in this experiment. From raw code mix data, we use some pre-processing steps and labeling. So basically converting all characters to lowercase, converting slang word into standard one, converting number to textual representation, removing punctuation, special symbols, stop word, and white space, and URL address if necessary. And then we split the data into two parts, which is called training dataset and testing dataset respectively. For each dataset, we translate it into English to obtain equivalent word, and then we extract sentence representations, okay? Or maybe known as sentence embedding. All right, so this data is then used to train 5 machine learning models. Each model is then tested using training data set, and we measure performance of each model. Now, the data set for this study is a collection of relevant code mix sample of text crawled from Twitter social media in 2020 with bilingual code mix languages, Bahasa Indonesia and Eastern Java dialect of Javanese languages. The total sample is 891, comprises of 460 or 51.6% head speech label samples, and the rest is non-head speech label samples. The labeling process for input dataset is implemented by an expert who speak both Bahasa Indonesia and Javanese languages. And then for the training process, the input data is split randomly into training dataset and testing dataset with the proportions of 80% and 20%. And the experiment result, after we train 6 machine learning models, it appears that logistic regression achieved the best average accuracy, followed by a support vector machine. So some factors contributed to the sentiment analysis result. From these experiments, we found that the cultural and accuracy of machine translation model is very dominant. In cultural aspect, for instance, that many code mix of Bahasa Indonesia and Javanese languages is considered head speech by the classification models. However, it is considered as a common expression by East Java dialect of Javanese languages speaker. And accuracy of machine translation model is due to the use of standard Javanese languages for train the models. So it seems that the model has low generalization capability to recognize local dialect of Japanese languages. So as conclusion, head speech detection model to extract head speech from code mix text accurately is important to prevent offensive word in social media. And the popularity of Twitter social media in many countries, including Indonesia, in the past decade has provided a tremendous amount of data for head speech detection in the form of code mixed text, Bahasa Indonesia, and local languages such as Javanese languages. An experiment using SVM, logistic regression, Naive-Bayes, GNN, random forest, and gradient boosting trees classification model showed that the logistic regression model achieved the highest in terms of the average accuracy and precision. And developing a more robust sentiment analysis for code mix text involving Bahasa Indonesia and other languages to be used for head speech detection will be the next step of this research. In this opportunity, the authors would like to thank Ehsan from Prince of Songkhla University, Thailand, for providing access to Grid Computer Server. Also, this study is funded partially by Venus University under International Research Grant. This is my reference, and thank you very much for your attention.